Welcome to EDU World Space.
Hi, everybody. So this question is asking us, knowing what the amplitude of the motion is, determine the PM with potential magnitude, with periodic force. So right here, what we need to do is determine this. And they give us this equation here in the problem. So let's just make sure we have that written down. And we're given this as 10 radians per second, and k equals 1 kip of feet, and then we have a mass of 64 pounds. Okay, and so what we can draw is the diagram that they gave us, and this is before I start the problem to let you guys know everything. Here we have the mass. Here, this is the P, which is represented right here in this equation. And then we have the spring force, which is K. Okay? And so we had to consider the block attached to the spring as a system in a model if it is a single degree of freedom particle undergoing forced vibration. Okay? So we're looking at vibrational forces. So we're using this expression right here that they gave us in red. And we also are going to convert the spring force here to 1 kip feet to equaling to 1,000 pounds feet. And we need this into inches, so we're just going to divide it by 12 equals 83.33 IB per inches, okay, for the spring constant. And we also need to calculate the natural oscillatory frequency of the system, okay? And from there, we'll do the amplitude vibration, okay? And then we can get to solving the PM, okay? So again, we're just going to keep doing this very slowly to find the PM, and we're just using this equation here. So we are going to use here, and we have 1,000 over 64. That's 64 pounds, and 1,000 pounds per feet times gravity, 32.2, which is feet per second. And this is going to be 22.43 radians. Oops, I have per here, don't need that. Per second. Okay. So we have to write the amplitude, which is the xm, to find the amplitude. And that's just going to be PM over K divided by 1 minus the frequency here. And the frequency Wn is what we found, okay? And so what we're going to do is just solve this PM here, okay? Because what we're trying to do is solve for what we know. So we'll be able to solve the PM with the information that we're able to get from the problem. Sometimes physics is like that. They trick you with an equation you don't quite need. Because if you noticed, there's no sign here. You don't know the angle. And since you don't know the angle, you can't quite do this yet because you have to figure out what this is. So this is what we're trying to do, is figure out what this is. And then later on, and right now you don't have to solve it, you can solve this pretty easily because you're going to know what this is, and you just need to know the t. But right now we don't need to know the t. So we found this PM through the amplitude. Yeah, okay. And now we can just kind of plug and chug what we have. So we have 83.33 that we found for the spring constant times 0.75 for the xm, for the amplitude. And now we have 1 minus 10 over here. over 22.43, and we just found 22.43, and the 10 was given to us in the problem, squared, and you put this into your calculator, and you get 50.075, which equals 50.1 pound. And that is your PM, guys. Thank you.